In this video, I'm going to take a look at the oscillator page of Virus Control and explore the capabilities of the Classic Oscillator mode. Classic is the name we have given to the oscillators which were used in the Virus A, B and C series to distinguish them from the additional models which have been added to the TI series. And I think it's fair to say that their flexibility and character have played a major part in the success of the virus. Now, there's a fair amount to talk about with these oscillators, so I'm going to present them in two parts, and in part one, I'll be focusing only on oscillator 1. So firstly, I'm just going to set oscillator balance all the way to the left. So for now, we'll only be able to hear oscillator 1. Now, in classic mode, the main central controller here is used to control the shape of the waveform. It defaults to the 12 o'clock position, as it is now, and the oscillator will generate a pure sawtooth wave like this. If I turn it fully clockwise, it'll generate a square or pulse wave. And any values between these points will generate a mixture of saw and pulse. And as you can see, the graphic display in the center of the controller will give you a very good idea of the balance between the two. Now, when shape is set to pulse or anywhere between saw and pulse, you can adjust the width of the pulse wave by clicking on the display here and dragging it to the right. I'll just make it a pure pulse wave for now. Listen to how it affects the sound. It makes it thin and reedier as you approach the maximum pulse width. And at maximum, the sound will disappear altogether. So there are a wide variety of timbres you can achieve with this, but also something really interesting happens when you use an LFO to continuously modulate the pulse width. Let's just head over to the LFO page for a sec. And here we can use LFO1's pre-assigned pulse width modulation controller to do this for us. Now, I've increased the amount of pulse width modulation there, but the rate of the LFO is a little slow. I'm just going to turn it up a bit faster. And what we have here is in fact the equivalent of two detuned saw waves, but coming from a single oscillator. So you can use this technique to achieve a nice warm sound that uses very little resources and is therefore capable of very high polyphony. So let's move shape all the way over to the other side now. At this setting, what you hear is the very simple sound of a pure sine wave, which you can also blend with the saw. But sine is not the only option we have here. You can also choose from a selection of what we call spectral waves, which include a triangle and 62 other waveforms, many of which are very digital in character. You can also choose from the list by clicking on the little arrow. Notice how the parameters displayed in this area have changed since I moved the shape controller to the left of center position. So to edit the pulse width again, you first must make sure that shape is somewhere to the right of center position. We also have 4 additional controllers. Semitone adjusts the basic pitch of the oscillator in semitone steps. So to adjust it by an octave, you want to transpose it by 12. You can actually go plus or minus 4 octaves from the default setting. The controller here allows you to use velocity, which is how hard you hit the keys, to control the waveform shape. So if shape is set all the way to the left, I'll want to set velocity to oscillator 1 shape to the right. And now, as I hit the keys harder and harder, you can hear the sound change from the spectral wave all the way through the saw and to that nice warm pulse width modulation sound we made earlier. Just reverse those settings if you want it to work the other way around. Key follow allows you to change the way the pitch of the oscillator follows the keys as you play up and down the keyboard. At the default setting of +32, it'll behave as you expect, and more often than not you'll want to leave this well alone. However, it can be useful to set it to 0, which is in the center here, if you want the sound to be the same right across the keyboard, which often makes sense with percussion sounds, for example. Any other values are only really useful if you want to create sounds which don't behave in a conventional fashion. With this controller here, you can select the sub-oscillator waveform shape. The sub-oscillator generates a waveform that is exactly 1 octave below the main waveform being generated by oscillator 1. And to hear it, you need to turn up its dedicated volume controller, which is here in the mixer section. Then you can choose between square and triangle by clicking on the appropriate waveform shape. There are also a few other parameters which are worth looking at when you're just working with oscillator 1. Portamento, here in the oscillator common section, causes the pitch to glide from one note to the next, like this. Which can be particularly effective in monophonic mode, which you can select in the common page here under key mode. All the mono modes mean that you can only play one note at a time. This parameter allows you to initialize the phase of the oscillator every time you play a new key, and it makes the start of the note a lot more predictable, and it's another parameter which is very useful when you're making percussion sounds. Velocity to pulse width allows you to control the pulse width of both oscillators according to how hard you hit the keys. And punch intensity determines the volume of the little click that you can sometimes hear at the start of a note. It's most noticeable on sine waves. If you want to add some white noise to your sound, you can do so by turning up the volume of the noise generator here. And once you have activated it like this, then you can adjust the tone of the noise with the noise color parameter here. The ring modulator allows you to add further color to the sound, and the results of this will vary dramatically depending on the pitch and waveform of oscillator 2, as the ring modulator generates a signal by combining the sum and difference frequencies between the two oscillators. Finally, the oscillator volume slider controls the overall level of the combined output of the oscillators, with maximum volume being at center position. Beyond this, you will add increasing amounts of saturation at the filter stage, but only if you have selected a saturation curve in the filter section. Note that oscillator volume will have no effect on the levels of noise or ring mod, as their volume controls behave independently. In the next part of this tutorial, I'll be explaining the special functions of oscillator 2 and 3, including sync and frequency modulation.